Okay, hello, good evening everyone. Can everyone hear me? Tell me, can everyone hear me?
Yes, sir. Good
Rishabh,
evening, sir.
Imon, can you
Yeah.
people hear me? Yes.
Yes, sir.
Yes, sir.
So, Imon and Rishabh, did you people go through the recordings? Tell me.
Sir, I have gone through all the three recordings, but the third one, when it was not so, when I could not remember all the things, but first two were perfectly done.
Okay, okay. After the
Uh,
class, yes, tell me,
yes,
Imon,
sir.
tell me.
No, no, sir. Yes.
After the class, you text me. I'll send you the, PDF notes also. Okay.
Okay, sir.
Okay. Okay, so everyone, let us continue. Last day we were doing functions. Okay, I had given some homework questions, but few people have not sent me their homework. Or if did you send? Or if Shubhankit,
Sir,
what
done it and
happened?
forgot to send. I'll send after the class.
Should have sent it. Or if Shubhankit and
Yes, sir.
who
I'm also
else?
forgot to send.
Madhurja also didn't send. Okay, I think Abhiksha also didn't send this time. What happened? Tell me. Send your homework. Be regular. Okay, I think Ahir also didn't send. What happened?
Sir, I sent it. I forgot.
Okay, try to be regular, everyone. Okay, it's high time. Only 6, 7 months are left. Okay, everyone, pay attention. So last day we had done. We were doing functions. Pay attention. Okay, so I had given some homework questions. Let me see. Okay, I'm going to write down the answers. Okay. Okay, first one over here. The answer is 5 comma infinity union elemental 4. Okay, first one. The answer is 5 comma infinity, 5 closed to infinity, union elemental 4. Anyone having any doubt, you can ask me now. Next. Second one, the answer is 0 comma 2, close closed, union 3 comma infinity, closed open. Is anyone having any doubt? You can ask me. Third one, the answer is 5, null set. Fourth one, the answer is minus infinity comma 0. Fifth one, the answer is 2n pi plus pi by 6. If there's anyone having any doubt, you can ask me now.
Sir, can you solve question number 5?
Okay. I'm solving one part 5, everyone. Pay attention. Okay. It's given root over sine of cos x plus ln of minus 2 cos square x plus 3 cos x plus 1 plus log of. Okay. So over here, your main focus should be on the third term. Why I'm telling you, everyone pay attention. Over here, your main focus, you should completely focus on the third term. Pay attention. It's given root over sine of cos x plus ln of minus 2 cos square x plus 3 cos x plus 1 plus root over log to the base 4. Okay, pay attention, everyone. This is number 1 part 5. Okay, so everyone, in the third term, this element should be greater than or equal to 0. Okay, this element should be greater than or equal to 0. That means this whole thing, should be greater than or equal to 4. Can you people realize this? Tell me. This element 4 upon, oh sorry, uh, this element should be greater than or equal to 1, not 4. Okay, means 4 upon 3 plus 2 sin x plus 1 upon 2 root 2 sin x. Okay, must be greater than or equal to. No, it cannot be equal to 1. No, it can be equal to 1. So greater than or equal to 1. Tell me, can you people realize this? Yes or no?
Yes, sir.
Okay, next. Over here, try to understand. From here, we can say that 3 plus 2 sine x plus 1 upon 2 root 2 sine x must be less than or equal to 4. Can you people understand? Yes or no? I have taken 3 plus 2 sine x upon 2 root 2 sine x to the right hand side. Okay, this should be less than or equal to 4. That means 2 sine x plus 1 upon 2 root 2 sine x must be less than or equal to 1. Okay, taking 2 root 2 sine x to the right hand side, this implies 2 sine x plus 1 is less than or equal to 2 root 2 sine x. Okay, so Adrisha, are you able to see a perfect square? Tell me. If you take 2 root 2 sine x to the left hand side, you'll get 2 sine x minus 2 root 2 sine x plus 1 must be less than or equal to 0. Tell me, are people getting? Yes or no? Others are getting this? Tell me. Rishabh, Imon, are people getting?
Yes, sir.
Yes, sir.
Parvev, Pratyay, are people getting? Yes or no?
Yes, sir.
Shanaya, are you getting? Okay.
Yes, sir.
Shreyasi, are you getting this?
Hello, sir. The sin x should be inside the root.
Okay, no. Even if you take, yes, you are correct only. It should be inside the root. You're correct. I took it outside by mistake. But see, still it is perfect square, right? It's root over 2 sine x whole square. Tell me, Shavankit, are you getting? Minus 2 into root 2 sine x into 1. Root 2 sine x into 1 plus 1 square must be less than or equal to 0. Tell me. Hello, Shreyasi, you also didn't send me your homework. What happened?
So I forgot this time.
Don't forget. Every week you are forgetting. Whenever you are solving some problem, send it. Is it clear?
So I'll send like the Sunday and this one by tomorrow.
Okay. Root 2 sin x minus 1 whole square must be less than or equal to 0, everyone. So tell me, can a perfect square ever be less than or equal to 0? Tell me. Can a perfect square ever be less than or equal to 0? I mean, it cannot be less than 0, right? So the
It can
only
be
thing,
0 but not less than 1.
exactly, this equation will only work if root 2 sin x minus 1 must be equal to 0. This is the only possibility. There's no other possibility. Can you people understand? Yes or no? Tell me. Adrisha, are you getting?
Yes.
Okay. Iman, have you understood? Tell me.
Yes, sir.
Okay. So from here, I'm going to find out the value of sin x. Okay. Taking 1 to the right hand side, we'll get root 2 sin x is equal to 1. This implies sin x is equal to, I guess, half. Yes. If sin x is equal to half, this implies x must be equal to 2n pi plus pi by 6. Done. Okay. But you have to check whether the other terms are defined or not. Okay. At x equal to 2n pi plus pi by 6. At x equal to 2n pi plus pi by 6, what is the value of cos x? Tell me, everyone. What is cos of 2n pi plus pi by 6? Tell me.
Root 3 by 2.
Root 3 by 2. Okay. So just checking whether log will be defined or not. Okay. I'm going to substitute 2 into 3 by 4. Sorry, minus 2 into 3 by 4 plus 3 into root 3 by 2 plus 1. Is it positive? Tell me, everyone. This is minus 3 by 2
Yes, sir.
plus
Positive.
3. Yes, it is positive. Absolutely correct. So, yes, the second term is also defined. I guess the first term will also be defined. So, yes, this is your domain. Tell me, is it clear, everyone? Okay, anyone having any doubt, you can ask me. Shavankit, is it clear? Shamili, Shanaya, Shrita, Shubhangi, is it clear? Ritam, Pratyay, Ashishwari,
Yes, sir.
is it clear?
Yes, sir.
Sir.
Okay, next, let us move on to the other one. We need to find out the domain and range of box of sine of fractional part of x. Okay, so over here, the domain is Domain is all real. You can substitute anything. Okay. And range of the function is only elemental 0. Okay. Next, part 2. Part 2, the domain of the function is elemental 0, 1, minus 1 by 3, 8 by 3. And range is only elemental 0. Anyone having any doubt, you can raise your hands. Tell me, you can ask me now.
Yes, sir. I'm pleased to do it.
Okay. This one also I'm solving. It is log to the base 3, 4 upon 4 plus. Okay. So if you notice, okay, Shubhankit, in this sum, if you notice that in the denominator, the power is 2024, right? So are you able to understand that the power is even? Can you understand? Tell me.
Yes, sir.
The power is even. And this has to be greater than or equal to 0. The power is even. So, Shubhankit, can you understand that this is already greater than or equal to 0? Right?
Yes, sir. This whole thing is positive only.
This whole thing is positive. So 4 plus this whole thing, the denominator is something greater than or equal to 4? Yes, tell me, Shwankit, are you getting? 4 plus something greater than or equal to 0. The denominator is something greater than or equal to 4? Yes or no?
Yes, sir.
Okay. That means, can I say that the whole thing, I mean, this is nothing but log of something less than or equal to 1 to the base 3. Right, tell me. Are you getting, Shwankit?
Yes, sir.
Okay. Rishabh, are you getting this?
Yes, sir.
Okay. Imon, are you getting?
Yes, sir.
Joytra, are you getting? Advito
Yes, sir.
and Risha, are you getting?
Yes, sir.
Okay.
Yes, sir.
Log of something less than or equal to 1 to the base 3. Now try to understand. Whenever the number is less than 1, whenever the number is less than 1, the whole logarithm will become negative. Yes or no? Right, Shwankit? Log of something which is less than 1 to the base something which is greater than 1. They both are on opposite sides of 1. This will become negative. Can you understand? Tell me.
Yes, sir.
Okay. So if this becomes negative, this can only work if the whole thing is equal to 1. Yes or no? Tell me, Shwankit. This can only
Yes,
work
sir.
if the whole thing is equal to 1. Otherwise, it's not possible only. Okay. So what can we
Yes,
say?
sir.
This implies, and if this whole thing is equal to 1, this implies box of x square plus, sorry, box of x square minus box of x minus 2 into fractional part of x must be equal to 0. Okay. Then only it is possible. Otherwise, it's not possible. Tell me.
Sir, the middle term, why is it box of x?
Oh, no, not box of x. Only x, only x. My bad. Okay. Only x. Tell me. Shavankit, are you getting? Now we have to
Yes, sir.
solve this equation. Okay. Box of x square minus x minus 2 into fractional part of x is equal to 0. Okay, so let's start. So box of x square. Okay, converting into box of x and fractional part of x. This will be box of x square minus box of x minus fractional part of x minus 2 into fractional part of x is equal to 0. Okay, so I need to find out the value of x from here. Okay, so what are we getting? From here, box of x square minus box of x. Okay, minus fractional part of x minus 2 into fractional part of x will become minus 3 into fractional part of x. Okay, this is equal to 0. Okay, taking 3 into fractional part of x to the right hand side. Okay, this implies box of x square minus box of x. This will be equal to 3 into fractional part of x. Okay, from here we have to think about the inequality. Okay, also you see 3 into fractional part of x means this will lie between 0 and 3, or you can see 3 into 0 comma 1. This will lie between 0 comma 3. Okay, box of x square minus box of x must be equal to 0 comma 3. Tell me, are you getting Shubhankit?
Yes, sir.
Okay, next. After this, we need to understand the values of x for which this will satisfy.
So
Okay,
should be closed right now.
0 should be closed. Closed. Okay. First of all, x can be equal to 0. Okay, you can see x equal to 0. Box of x square minus box of x. Okay, x can be equal to 0. Okay. After this, box of x, can it be equal to 1? Box of x can be equal to 1 also. Okay. Next. After this, box of x can be equal to
-1/3.
wait a minute, not like this. Okay, box of x can be equal to 2. 2 square minus 2. Box of x can be equal to 2. Okay. Next, box of x can be equal to 3. 3 square minus 3 cannot be equal to 3. Box of x cannot be equal to 3. Can it be negative? Box of x, can it be negative? -1. Box of x is negative, so this will become -1 whole square. Okay, that will give us 1 minus of -1. So this will give us how much? 1 plus 1, 2. Yes, box of x can be negative also. Box of x can be equal to -1. Okay. And anything else? Box of x, can it be equal to -2? -2 square, 4. 4 minus of -2, that is outside the range. So I think these are the only possible values of box of x. Right, tell me, Shavankit.
Yes, sir.
Okay. Now, if box of x is equal to 0, so what is the fractional part of x? Tell me. If box of x is equal to 0, fractional part of x is equal to 0 only. You see this equation? If box of x is equal to 0, fractional part of x is equal to 0. If box of x equal to 1, what is the fractional part of x? If box of x is equal to 1, what is the fractional part of x? Tell me. 1 square minus 1, 0. So
So
fractional
zero
part of
only.
x is equal to 0. If box of x is equal to 2, what is the fractional part of x?
Zero.
Why? 2 square is 4. 4 minus 2 is 2. So 2 by 3, right?
Oh yes, yes, sir. That's a bite.
Yes. If box of x is equal to -1, what is the fractional part of x? Tell me. Fractional part of x will be equal to
2/3.
2 by 3. It's also coming 2 by 3 only. So now let us find out the value of x. Therefore, x will be equal to, from the first case, it is 0, then 1, then 2 plus 2 by 3, that is 8 by 3, and lastly, -1 plus 2 by 3. -1 plus 2 by 3 will give us how much? -1 by 3. Yeah, this is the answer given. Let's check. Oh yes, 0, 1, -1 by 3, 8 by 3. Tell me, is it clear, Shavankit?
Yes, sir. Yeah.
And so the range will be, therefore the range of the function will be only elemental 0. Tell me. Because log of 1 is 0, right? Just because log of 1 is 0, so it will be only elemental 0. Is it clear, Shovankit? Tell me.
Yes, sir, clear.
Okay.
Sir,
Yes, tell me, Shravani. Oh, Abhishek, tell me.
sir, over there, why are you considering 0, comma 1?
Which one? Where? Oh, like why am I considering 0 and 1?
No, no, no. Over there, 3, then close interval 0, comma 1.
Because the range of fraction part of x is 0, comma 1 only. So I need to check where does this equation lie. Are you getting? I need to restrict it between an interval.
Okay, sir.
Tell me, Abhishek. Fraction, just because fractional part of x lies between 0 and 1. Okay. Actually, this should be close brackets. Okay. So the right hand side, the range of the right hand side is from closed open 0, comma 3.
Okay,
Right,
sir.
tell me, Abhishek.
Yes, sir.
So, so the left hand side cannot lie outside this range. Can it lie outside this range?
No,
It's not
sir.
possible. So that's why I restricted it on the right hand side.
Okay, sir.
Okay. Is it clear to others? Tell me. Adrija, Ahir,
Yes.
Srijita, Shashwato, is it clear? Shubhangi?
Sir, can you again explain that why did you take that 0, 1, 2, and -1 values?
Yes. Because you see, once I restricted the range on the right hand side, closed open 0, comma 3. Okay, I need to check box of x square minus box of x. I mean, for what values of x, box of x square minus box of x is lying in this range. Okay. First for 0 will work because 0 square minus 0 is equal to 0. Right, it lies in the range. Right, tell me, Shashwato.
Yes, sir.
Next, 1 square minus 1 will also work, lies in the range.
Yes, sir.
Then 2 square minus 2 will also work, lies in the range.
Yes, sir.
Okay. 3 square minus 3 is equal to 6. It does not lies in the range. So that's why I didn't pick 3.
Okay, sir. Understood.
Yes. And then I started with -1, some negative values.
Okay, sir.
Okay. Okay. Tell me, Ritam, Pratyay, Madhurjo, Imon, Rishabh, are you people getting?
Yes,
Yes.
Yes,
sir.
sir.
Yes, sir.
Okay. Next. If there's anyone having any doubt, you can ask me now. Okay. Next. Number three, the answer is 75. Very easy. Hermite's identity. Anyone having any doubt, you can ask me now. So draw the graph y equal to box of x square. Let us start. I need to draw the graph of y equal to box of x square. Everyone pay attention. This is number 4. F of x is equal to box of x square. What is f of minus x? F of minus x is equal to box of minus x whole square, which is box of x square only. So can I say that the function is even? Tell me. This implies the function is even. If f of x is equal to f of minus x, the function is even. That means whatever you draw on the right hand side, same thing you draw on the left hand side. Okay. This implies the function is symmetric over y-axis. The function is symmetric over y-axis. Okay. Now let us draw, everyone. Acha, wait. Before drawing, first of all, let us break it piecewise. So f of x is equal to box of x square. Can I say it is equal to 0 for x square lying between 0, comma 1? Tell me. Yes or no? Can I say it is equal to 0 for x square lying between 0 and 1? Next. When will it be equal to 1? It will be equal to 1 when x square belong to 1, comma 2. Right. Box of x square will be equal to 1 when x square belongs to 1, comma 2. Right, everyone, tell me. It will be equal to 2 when x square is equal belongs to 2, comma 4. Okay, and so on and so forth. Sorry, not 2, comma 4, 2, comma 3. Okay. So what does it imply? This implies x should belong to 0, comma 1. So you have to draw the graph of y equal to 0 for x equal to 0, comma 1. This implies x should belong to 1, comma root 2. This implies x belongs to root 2, comma root 3. Okay. So let us plot the graph. On the right hand side, you have 0, 1, root 2,
Yes, sir.
root 3.
So
Yes, tell
why,
me.
why aren't we taking the minus values?
Because whatever graph you draw on the right hand side, same graph you draw on the left hand side. The function is even, right?
Yes, sir.
It
So
is
we will have
symmetric over
to
there.
just.
Yes. F of x is equal to f of minus x, right? Means whatever graph you have drawn on the right hand side, same thing you draw on the left hand side, right? You will remember the logic of even and odd function. Tell me, so Ankit, is it clear?
Yes, sir.
Okay. Emon and Rishabh, you people know, right? What are even functions?
Yes, sir.
Okay. So Rishabh, are you getting? Okay. This is 2. Okay, and so on. Okay, how will the graph look like? First of all, from 0 to 1, y equal to 0. Okay. One will be open, others will be closed. Then from 1 to root 2. From 1 to root 2, it will look somewhat like this. From root 2 to root 3. Okay. It gets smaller. Can you people understand? It gets smaller and smaller. Okay, this is how the graph will look like. Okay, and same thing, you just copy and paste on the left hand side. Oh, wait, not like this. Wait, not like this. Oh, wait, I have to draw it only. Okay. So anyone having any doubt, tell me. You can ask me now. Oh, wait. So has everyone understood the graph? Rasheshwari and Visha, are you people getting?
Yes, sir.
Okay. So this is how the graph will look like. So anyone having any doubt, you can ask me now. So Abhiksha, is it clear? Joyatra, is it clear? Madhurjo, have you
Yes,
understood?
sir.
Yes,
Sanaya,
sir.
is it clear?
Yes, sir.
Okay, next. Next is, okay, so we have drawn the graph of y equal to box of x square. Number 5. Number 5 came in JEE means the answer is minus infinity, comma, wait, let me check, minus infinity, comma, minus 2, union, close 6, comma, infinity. So anyone having any doubt with number 5? Number 5, okay. We need to find out the domain of the function f of x is equal to 1 upon root over box of x square minus 3 into box of x minus 10. So this function is only defined when this function is only defined when box of x square minus 3 into box of x minus 10 is strictly greater than 0. It cannot be equal to 0 also, right? it cannot be equal to 0 also. Right? It has to be strictly greater than 0. Okay. Next. So after this, let us simplify. So it becomes a quadratic. Okay. For the time being, I'm taking box of x as t. So you'll get t square minus 3t minus 10 is greater than 0. Okay. You can factorize. You'll get t square minus, wait a minute. Just checking any other condition given. No. Okay. So t square minus 3t minus 10 is greater than 0. So after this, you'll get t square minus 5t plus 2t minus 10 is greater than 0. So from here, you'll get t common, t minus 5 minus 2, t minus 5 must be greater than 0. Okay, this implies, oh, t minus 2 into, sorry, t plus 2. T plus 2 into t minus 5 must be greater than 0. So what does it implies? It implies t belongs to minus infinity comma minus 2, open, union, open 5 to infinity. Right, tell me. So what does it implies? It implies box of x is either less than minus 2 or box of x is greater than 5. Right, tell me, Shamli. Yes or no? If box of x is strictly greater than 5, this implies x belongs to open, wait a minute, closed 6 comma infinity. Right, tell me. Even if it is 5.99, it will become 5 only. So close 6 to infinity. And if box of x is less than minus 2, this implies x is less than minus 2. This implies x belongs to minus infinity comma minus 2 union 6 comma infinity. Yes, tell me, Shamli. Means this box of x greater than 5. Over here, you tell me when will the greatest integer of a number be greater than 5? That means box of x has to be equal to 6. Right, tell me. It's an integral value, right? The least possible value is 6. Right, Shamini? So it has to start from 6. It cannot be 5.99. Box of 5.99 is 5 only. Tell me. Are you getting Shamini? Okay. Yes. Imon, have you understood? Shreyasi, Shubhangi,
Yes.
Shubhankit, are you people getting?
Yes, sir.
Okay. So next, so everyone, I have discussed all the homework questions. Let's see what have we done for last day. Okay, last day I had discussed this problem. Okay, so let us continue from here. So this was the last thing we had discussed. Just give me 1 minute. Okay. Hmm. Okay, everyone try this out. Question number 1. Find the range of, find the range of number 1, cot square x minus pi by 4. Number 2, log of base 10, base 1 by 10, x square plus 2x plus 2. Number 3, 2 minus box of sin x minus box of sin x whole square. Next, okay, part 4, x plus 1 by x. Okay, quickly solve. Part 5, x minus box of x upon 1 minus box of x plus x. Okay, keep on solving, everyone. Tell me. Yes, Adija, 1 part 1 is correct. Okay, everyone, I'm solving 1 part 1. Pay attention. Yes, Aditham, 1 part 1 is correct. Abhisha, check 1 part 1. Okay, everyone pay attention. It's cot square x minus pi by 4. Yes, Rashishwari, 1 part 1 is correct. Cot square x minus pi by 4. Iman, 1 part 1 is correct. Yes, Azito, 1 part 1 is correct. Rashishwari, 1 part 2 is correct. Shubhangi, 1 part 1 is correct. Rashishwari, 1 part 3 is correct. Aditham, 1 part 2 is correct. Ajito, check 1 part 2. Oh, no, wait. Okay, Rishabh, 1 part 1 is correct. Check 1 part 2.
Sir, I haven't sent part 2.
No. Actually, your number
Okay,
and Rishabh's number is quite similar, so that's why I
okay,
got confused. Okay, Abhipsha, 1 part 1 is correct. Now, part 2 is also correct. Keep on solving, everyone. Yes, Shubhangi, 1 part 2 is correct. Madhurjo, 1 part 1 is correct. Rishabh, check 1 part 2. Okay, I'm starting, everyone. Cot square x minus pi by 4. So try to understand, everyone. It's cot theta. Cot theta, the range of cot theta is minus infinity to infinity. Okay, so when you substitute and square minus infinity comma infinity whole square, this will give us closed, opened, 0 comma infinity. Remember. Okay. Yes, Rasheshwari, 1 part 4 is correct. Adrija, 1 part 2 is correct. Ritam, I think you are not using the brackets properly. Yes, Rasheshwari, your answer is correct. Okay, next. Part 2. Part 2, it is written log to the base 1 by 10, x square plus 2x plus 2. Can you people understand that the discriminant of x square plus 2x plus 2 is less than 0? B square minus 4ac is less than 0. So we need to find out the minimum value. What is the minimum value, everyone? Minimum value of x square plus 2x plus 2 is 4 into 2 minus b square by 4a. This will give us 8 minus 4 by 4, that is 1. So basically, what is the range? Therefore, range is log of base 1 by 10, open 1 to infinity. Okay. So now see everyone, the base lies between 0 and 1. How will the graph of log look like? The graph of logarithm will look somewhat like this. Okay. So we need to find out all those values of logarithm such that x lies between 1 to infinity. So whenever x lies between 1 to infinity, whenever x lies between 1 to infinity, logarithm lies from 0 to from minus infinity to 0. Can you people understand? This will give us minus infinity, comma 0. Also, you can see it from here. Okay, log of 1 is 0, and log of infinity to the base 1 by 10. Log of infinity to the base 1 by 10. Wait a minute, I'm making a mistake. Log of infinity to the base 1 by 10. Wait a minute. Log of infinity to the base 1 by 10. Where is infinity? Infinity is over here. And to the base 1 by 10 is 0. Actually, log of infinity to the base 1 by 10 is 0. Oh, wait a minute. I'm making a mistake, I guess. Oh, I have to find out the range. Okay, that means the y-axis, which it is covering. Okay. So again, when x is equal to 1, it should be 0. When x is equal to infinity, yes, minus. Yes, I have done it correctly only. So it will be minus infinity, comma 0. Tell me, can everyone understand? At x equal to infinity, you are going to get minus infinity. Tell me. Tell me, Rishabh, are you getting this one?
Yes, sir.
So it will be minus infinity, comma 0. Anyone having any doubt, you can ask me now. Okay. Everyone solve.
Sir, can you please explain the last part?
Yes,
Minus
Imon.
infinity.
Yes, Imon, see, it's log of 1 to the base 1 by 10. Log of 1 to the base 1
Yes,
by
sir.
10 is 0. You can see
Yes. Yes, sir.
corresponding value will be 0. Next, at infinity, what is happening? That you have to check. So, Imon, see, at x equal to infinity, y is tending to minus infinity. Tell me, on the lowest
Oh,
part,
yes, sir. Yes, sir.
so the values will start from minus infinity and at 0.
Oh, okay, okay, sir.
Is it clear, Imon? Tell me.
Yes, sir. Yes, sir.
Okay. Okay, everyone solve. Part 2. Part 2 is done. Part 3. Okay, let's see who has done it. Yes, Imon, part 3 is correct. Or if part 1 is correct, part 2 is correct, part 3 is correct, part 4 is correct, part 5 is also correct. Ahir, Ahir, you are making some mistake in part 3. Shwankit, part Shwankit, I hope you have understood part 1. Okay, part 2 also you are making some mistake. Part 3, I think you're using wrong brackets. Check part 4 as well. Okay, Shashwato, Okay, Shashwata, I hope you have understood part 2.
Yes, sir.
Okay.
Sir, can you
Ritam,
show number 4?
yes. Ritam, part 4 is correct. Part 5 is also correct. Shubhangi, part 4 is correct. There's a slight mistake in part 5. Part 3 is correct. Shamali, part 4 is correct. Adrija, check part 3. Adrija, you need to find out the range. Remember. Adrito, Adrito, part 4 is correct. Part 3 is also correct. Abhipsha, check part 3. Madhurjo, part 4 is correct. Here, part 3 is. No, you are making some mistake with part 3. No, part 3 is correct. Here, part 3 is correct. Part 5 is also correct. Yes, Ritam, part 3 is correct now. Shamali, part 5 is correct. Okay, Adrija, part 3 is correct. Uh, actually, Ritam, can you hear me?
Yes, sir.
No, no, not Ritam. I mean, Imon, can you hear me?
Yes, sir.
Okay, Imon, a quadratic is always defined. Okay, I mean, quadratic will give us real roots if the
Oh, sorry,
discriminant is
sir.
greater
Yes,
than.
sir. Yes, yes, I meant that. Sorry, sorry, sorry.
Yes. Okay, okay. Yes, Shubhangi, number 5 is correct. Part 5 is correct. Shashwato, Shashwato, check part 4. There's a slight mistake. Part 3 also, check part 3. Imon, check part 3. Abhipsha, check part 5. Part 3, you are using wrong brackets. Anvesha, part 4 is correct. Check part 5. Everyone pay attention to part 3. It's 2 minus box of sin x minus box of sin x whole square. Try to understand box function will always give us integral values. Box function will always give us integral values. Part 5. Part 3. Part 3. Box function will always give us integral values. Now try to understand. Sin x belongs to. Sin x belongs to closed minus 1 comma 1. Tell me the integral values in this range. Tell me. Tell me the integral values in this range. Anyone? What are the integers that are lying in this range?
-1, 0, 1.
Minus 1, 0, 1. So you start substituting. For box of sin x equal to -1, what are you getting? 2 minus of -1 minus of -1 whole square. This will give us how much? 3 minus 1, that is 2. For box of sin x is equal to 0, you'll get 2 only. Right? F of x is equal to 2 only. For box of sin x is equal to 1, f of x will be equal to 2 minus 1 minus 1, that is 0. Okay, so there are only two values in this range. Therefore, the range of the function will be elemental 0, comma 2. Okay, are you getting? It should be elemental. Okay, it should not be third brackets, everyone. Tell me, anyone having any doubt, you can ask me now.
No, sir.
Okay. So, Shashi, are you getting?
Yes, sir.
So why not third bracket?
Because third bracket represents all real numbers, but we are only getting elemental values. Are you getting, Avisha? We are only getting elemental values. So it should be second brackets. No?
Okay, sir.
We are not getting a range. We are getting elemental values, discrete values. Yes, Rishabh, part 4 is correct. Okay, everyone, let us start with part 4. X plus 1 by x. Very easy, everyone. F of x is equal to 1, x plus 1 by x. Very easy. So if f of x is equal to x plus 1 by x, okay, if f of x is equal to x plus 1 by x, okay, over here we can use the AMGM inequality. X plus 1 by x must be greater than or equal to 2 into root over x into 1 by x, which is greater than or equal to 2. Okay, this is for x greater than 0. This is for x greater than 0. For x less than 0, what will happen? For x less than 0, x plus 1 by x must be less than or equal to 2 into minus 1. Okay. Actually, root over 1, this time it will give us minus 1. Okay. So this implies x plus 1 by x must be less than or equal to minus 2. Remember, for x less than 0. Okay, this implies x plus 1 by x belongs to minus infinity comma minus 2. Shashwata, are you getting? Union 2 comma infinity. Okay. Achha, let us see the graph of x plus 1 by x. Okay. Let us see the graph of x plus 1 by x. Graph of x plus 1 by x. Okay, let us start. Achha, what is the domain, everyone? What is the domain of x plus 1 by x? Tell me.
R
Domain
minus.
is
All
all
real
real,
All real minus elemental 0.
elemental 0. Okay. Remember, all real except elemental 0. Okay, so I'm going to find out some values at 0 plus 0 minus, what will happen. Okay. Achha, f of 0 plus just greater than 0. What will happen? F of 0 plus is equal to infinity? Yes or no? Tell me, everyone. F of 0 plus is infinity. F of 0 minus is also... No, f of 0 minus will be minus infinity. F of infinity will be infinity. F of minus infinity will be equal to minus infinity. Okay, these are some points we need to understand. Okay, let us find out whether there exists a maxima or a minima. Okay, you people can understand definitely there will be a minima and definitely there will be a maxima. Okay, why I'm telling you? Okay, but we need to find out how many minima and how many maxima. Pay attention. At f of 0 plus, it is infinity. And at f of infinity, it is infinity. So of course the graph is going below and then going up. So definitely there exists a minima. Okay. And same thing with the negative x-axis. Over here, f of minus infinity is minus infinity. F of 0 is 0 minus is minus infinity. So are you people able to visualize that there exists a maxima and minima? Yes or no? Tell me, everyone. Are you people getting? There exists a maxima and minima as well. We just need to find out at where will I get maxima or minima? So for this, what I'm going to do is I'm going to differentiate. Okay, what is f dash x? F dash x will be equal to 1 minus 1 by x square. Right, everyone? Let us substitute equal to 0. So everyone, from here, what is the value of x? X will be equal to plus minus 1. Right, tell me everyone. So one of them will be minima and one of them will be the maxima. This implies x equal to 1 is a point of minima. Why will it be a point of minima? Because f of 0 plus is infinity and f of 0 minus is equal to, sorry, f of 0 plus is infinity and at f of infinity is equal to infinity. And at 1, the at 1 the graph is turning. So when the graph turns at x equal to 1, this is how the graph will look like. Can you people visualize? Tell me. F of 0 minus, it is infinity. At x equal to infinity, it is infinity. At x equal to 1, it is turning. So of course, the graph will turn at x equal to 1. Tell me. Are you people getting? If you are unable to understand, you ask me. Tell me, Abhigyan, Ayubsha, Adrisha, Adrito, Arif, Imon, Rishabh, are you
Sir,
people getting?
can you please tell that? Oh, okay. I understood. The
You
turning
understood?
point. Okay.
Turning point. At x
Yes,
equal to
I got
1
it.
and minus 1, the graph will turn. Take a turn.
Yes.
Yes. Rasheshwari, Pratyay, Madhurjo, are you people getting? Shanaya, are you
Yes.
getting? Okay. Ritam, are you getting? Shashwato,
Yes,
Shijita,
sir.
Shreyasi, are you people getting?
Yes, sir.
Swankit, are you getting?
Sir, can you please explain me how x equal to 0, that part, and then x plus 1 by x less than equals to minus 2?
Oh, yes. Less than or equal to minus 2. See, x is negative. So it's a negative value, right? X plus 1 by x is a negative value.
Yes, sir.
So in this case, what will happen? X plus 1 by x divided by 2. Okay, must be less than or equal to square root of x into 1 by x, right? In this case, what will happen? It will be less than or equal to mod of, now see, try to understand. X is a negative value. This x is also a negative value. So I'm going to write down mod 1. Are you getting? Tell me.
Okay, sir.
And since x is negative, mod will open with a negative sign. Since x is negative.
Okay, sir, understood.
Okay. Next, coming back to this one. So Shashwato, you understood? I mean, how I'm drawing the graph?
Yes, sir.
Okay, f of 0 plus, f of 0 minus. Rishabh, are you getting?
Sir, can you explain me that y at x equals to 1 it will be minimum?
Yes, because try to understand. See, from the Cartesian plane only you will be able to understand. Okay, y at x equal to 1 will get a minima. We can differentiate it once more and check it whether y it is a minima, but you will understand from the graph also. So Rishabh, over here, f of 0 plus is infinity. That means the graph will start from this point. Tell me, Rishabh.
Yes.
Okay. Next, Rishabh, you can understand that the graph will reach at infinity. At infinity also means this point. Okay.
Yes.
Next, Rishabh, also you can see that the graph turns at x equal to 1. So where is x equal to 1? X equal to 1 is somewhere over here. Right, Rishabh?
Yes, sir.
Okay, that means the graph should definitely turn over here.
Yes, sir.
Once the graph turns from here, once the graph turns from here, you can understand, Rishabh, that x equal to 1 is the point of minima, right? Because x at x equal to 1 plus, it is again increasing. At x equal to 1 minus, it is decreasing. It is again greater than at x equal to 1. Tell me. Now is it clear, Rishabh?
Yes, sir. Thank you.
Yes. Same thing will happen on the in the third quadrant. Okay, this is how the graph will look like. If there's anyone having any doubt, you can ask me. Okay, it will not be parabolic, everyone. It will look somewhat like this. Okay, this is the graph of x plus 1 by x. Okay, and what is this line, everyone? What is these lines? There will be no portion of the graph in this range.
2 comma minus
2 comma minus 2. This is y equal to 2. This is y equal to minus 2. Anyone having any doubt, you can ask me now. Okay.
2. Sir, is x is equal to y or asymptote of this graph?
Yes. Y-axis is the asymptote of the graph because this y-axis will meet the graph at infinity. Right? Tell me, everyone.
Yes, sir.
So this implies y-axis is the asymptote of y-axis. Remember. Okay. Tell me. Shamini, is it clear? Have you understood the graph? Okay. Quickly, everyone solve part 5. Those who are still solving. Okay, we can check with Desmos also. Let's see whether the graph is correct or not.
So my question was, if x is equal to y will be a asymptote. Y axis
Oh,
is
x equal to
same.
y. Oh,
Yes.
wait a minute.
I mean, there has to be another asymptote, right?
Y. Wait, I'll check. Just give me 1 minute. Okay, this is x equal to x plus 1 by x. Tell me, are you people getting? Oh,
Yes, sir.
yes, we are getting the same graph. Acha. So you told me y equal to x. Y equal to x is also an asymptote. See, the blue line is meeting at infinity only. Yes, Ritam, so you are correct only. Okay, y equal to x is another asymptote. Okay, so you can write it down. Y equal to x is also an asymptote of the is also an asymptote of x plus 1 by x of x plus 1 by x. Okay, next. Okay, let us do another one.
Sir, how can we find that y equal to x is asymptote?
Okay, so over here you put y equal to x. What are you getting? You're going to get x equal to x plus 1 by x, right? Or you tell me.
Yes, sir.
This implies 1 by x is equal to 0. At what value of x you are going to get 0?
Infinity.
Infinity. Is it clear? Tell me.
Yes.
Therefore, the line y equal to x meets this graph at infinity only. Is it clear?
Yes.
Okay. Next, part 5 I'm solving, everyone. Part 5. Okay, x minus box of x upon 1 minus box of x plus fractional part of x. Pay attention. Okay. So what have we got? X minus box of x. Okay. X minus box of x upon 1 minus box of x plus x. Okay. So everyone, this will give us fractional part of x upon 1 plus fractional part of x. Okay. Which is equal to fractional part of x. I'm going to add 1 and subtract 1. upon 1 plus fraction part of x. Okay, this will be equal to 1 minus 1 upon 1 plus fractional part of x. Now, what is the range of fractional part of x, everyone? What is the range? Close to open 0, 1. Okay, this will be equal to 1 minus 1 by 1 plus close to open 0, 1. Okay, this will be equal to 1 minus 1 by 1, 2, open closed. So 1 by 1 is 1. Okay, 1 by 1 is 1 and 1 by 2 is half. So it will be open half to closed 1. Now 1 minus half is half, 1 minus 1 is 0. So it is closed open 0, half.
So I send you this only.
Let me see.
Sir, I also sent you this.
And I told you wrong.
You didn't say anything.
Yeah, you
Oh, I
didn't say
didn't say.
anything.
Okay. I just solved it. Yes, Shashwata, you are correct. Adrija also, you are correct only. Okay, next. Let us continue, everyone. Okay, there was a graph part. Okay. Okay, let us discuss some hyperbolic graphs. Okay. Graphs of y equal to 1 by x, y equal to 1 by 2x minus 1, and y equal to 1 by 3x plus 4. Okay, let us see how will the graph look like. So you people remember, right? Domain of y equal to 1 by x is all real except elemental 0. Okay. Let us draw the graph. You people remember, right? It's an isothermal graph, or you can say hyperbolic graph. Y equal to 1 by x is a rectangular hyperbola. Okay. Y equal to 1 by x is a rectangular hyperbola. Whatever graph you are going to draw in the first quadrant, same thing you draw in the third quadrant. Okay. Next. Also, you should understand why it is concave up, why it is concave down. Okay. So let us understand. Everyone pay attention. D2y by dx square. Acha, wait. Not like this. Okay. Okay, concave up or concave down. Okay. So everyone, if dy by dx is greater than 0, this implies the function is increasing. Right, everyone? The function is increasing. Okay. Next. And if dy by dx is less than 0, this implies the function is decreasing. I've already told you before. Everyone knows this. Okay. Let us understand when will it be concave up, when will it be concave down. Okay. But everyone, for this reason, in order to show you this, I'm going to take a concave up graph. So this is a concave up graph. Okay. Let us draw tangents. Okay, this is a tangent. Okay. This is a tangent. This is another tangent. Okay, this is another tangent. Okay, this is another tangent. Okay, let us understand the behavior of dy by dx. Okay. So for this tangent, are you people able to understand dy by dx is negative? Slope is negative. Can you people understand? For this tangent?
Sir.
For this tangent, slope is still negative. For this tangent, slope is 0.
0.
For this tangent, slope is
Then
positive.
positive.
And for this tangent, slope is more positive. Right. Okay.
Was
So are you?
steeper.
Huh?
The slope is steeper.
Slope is steeper, so more slope. Right.
Yes, sir.
Okay. Acha, so everyone, can I say? And see, it is concave up. So basically, dy by dx is increasing, right? From negative to positive. Dy by dx is increasing if the graph is concave up. The graph is concave up. Can you people able to visualize this? Okay. So can I say this implies d2y by dx square? What is d2y by dx square? It is d by dx of dy by dx only, right? d2y by dx square must be greater than 0 if f of x is concave up. Tell me, are you people able to understand? When will you get a concave up graph? Tell me. Anyone having any doubt? You can ask me. Tell me. Anvesha, Rasheshwari, Adrito, Madhurjo, are you people getting?
Yes,
Yes,
sir.
sir.
Shashwato, Ritam, Rishabh, Imon, have you
Yes, sir.
people understood?
Yes, sir.
Okay. Pratyay, are you getting? Arif, are you getting?
Yes, sir.
Okay. Next, let us think. So similarly, the the opposite thing will happen in concave down graph. Okay, pay attention, everyone. So it's a concave down graph. Okay. First of all, dy by dx is positive. Then dy by dx is a little bit lesser. Then dy by dx is equal to 0. Then dy by dx is negative. Right. So I hope you people can understand that dy by dx is decreasing. Right. So I can say dy by dx is decreasing if graph is concave up, sorry, concave down. Okay, this implies d2y by dx square must be less than 0 if f of x is concave down. Tell me, Imon, are you getting?
Yes,
Joyatra,
sir.
have you understood?
Yes, sir.
Okay, so let us talk about y equal to 1 by x. Okay, I'm going to differentiate twice and see. Okay, for example, y equal to 1 by x. Okay, this implies dy by dx will be equal to minus 1 by x square. This implies d2y by dx square will be equal to minus 2 by x cube. Okay, can you
Sir,
people
it will be
understand?
plus.
Oh, acha, it will be plus. Yes, you're correct only. 2 by x cube. Okay, d2y by dx square will be equal to 2 by x cube. It will be greater than 0 for x greater than 0.
Yes, sir.
Right. So are you people able to see? That is why the graph is concave up on the right hand side. Okay. And d2y by dx square is equal to 2 by x cube will be negative for x greater than 0. For x less than 0. So see the graph is, that is why the graph is concave down. Okay. I hope you people have understood. Okay. Next. Also you see over here at x equal to 0, the graph tends to infinity. This implies x equal to 0 is a vertical asymptote. Okay. X equal to 0 is a vertical asymptote. Okay. Next. So similarly, I'm going to draw the graph of y equal to 1 by 2x minus 1. Okay. So what you do is you identify the vertical asymptote. So over here, can anyone tell me what is the vertical asymptote? Raise your hand. Tell me.
Sir,
Raise your hand.
can
Raise
you
your hand. Don't
repeat
speak.
the
Okay. Here x is equal to half is the vertical asymptote.
sorry, sir.
Okay. Here x equal to half is the vertical asymptote. So what you do is you draw x equal to half. Okay. And then you draw the same hyperbolic graph. You'll get the result. You draw the same hyperbolic graph. Okay. You'll get your result. Anyone having any doubt, you can ask me now.
Sir, can you scroll it?
Okay. Wait. Tell me, Shavankit, Adrija, is it clear?
Yes, sir.
Abhipsha, have you understood?
Yes, sir.
Okay. So you people also try one.
Okay, sir, thank you.
Okay. You people also try one. Okay. Once you have done it, you have to send me the graph. Okay. Question number two. Draw the graph of draw the graph of 1 upon 3x plus 4. Okay. Once you have done it, just send me the graph. Yes, Ritam, your graph is correct. Rishabh, your graph is correct. Okay. Jatra, your graph is correct. Shavankit, your graph is correct. Anvesha, your graph is correct. Adrija, graph is correct. Shubhangi, your graph is correct. Okay. Yes, Shashwata, can you hear me?
Yes, sir.
Okay. D2, if d2y by dx square equal to 0, it can mean two things. One is it can happen that it is a point of inflection. Okay. That we are going to discuss in application of derivatives. So wait for some time, you will understand. Okay.
Okay.
What will happen in d2y? Over the, no, there can have, I mean, it can happen only one thing, that there exists a point of inflection. We'll discuss. Okay.
Okay, sir.
Yes, Rishabh, your graph is correct. Well, your graph is correct. Shamali, your graph is correct. Imon, your graph is no, Imon, you are making a mistake with the graph. Wait. Oh, I'm looking it alternately. Okay. Yeah, Imon, your graph is correct.
Okay, sir.
Okay, Protyo, your graph is correct.
Sir, could you show the title of this part once more? I couldn't copy it. Okay, sir. Thank you.
Sir, you are muted.
Hello, can everyone hear me now?
Yes.
Okay. So in the previous example, we got that at x equal to 0, we'll get a vertical asymptote. Okay. But can you people tell me, uh, at x equal to infinity, what is the value of y? Tell me.
0.
0. So can I say that y equal to 0 is the horizontal asymptote? So there are two asymptotes, everyone. You should remember. Every hyperbolic graph would have two asymptotes.
Asymptotes. So in this case, y equal to 0 is the horizontal asymptote.
Exactly. Exactly. Y equal to 0 is a horizontal asymptote. Okay. Next. Why it is important? You will understand in the next example. Okay. To understand where will you get the vertical asymptote, where will you get the horizontal asymptote, it is important to understand. Okay. So my next topic is, okay, first of all, I'm going to generalize. Okay. If y equal to 1 by ax plus b, okay, or a not equal to 0, okay, then number one, domain is all real except minus b by a. Next. Number two, uh, number two, x equal to minus b by a is the vertical asymptote. And number three, y x-axis, that is y equal to 0, is the horizontal asymptote. Remember. Okay. Next. Our next topic is y equal to linear by linear. What will happen in case of linear by linear? Okay, so I'll give you an example and I'll draw the graph. So for example, y equal to 2x plus 4 upon x minus 1. See, I need to find out vertical asymptote. I'll have to find out the horizontal asymptote and how will the graph look like. So everyone pay attention. First of all, let us differentiate. Okay,
Sir, could you spell out
y
it?
y dash will be equal to x minus 1 into 2 minus 2x plus 4 upon x minus 1 whole square. This will give us 2x will get cancelled. You'll get minus 6 upon x minus 1 whole square. So tell me everyone, is this positive or negative? It's less than 0 always. Denominator is a perfect square. Numerator is negative. It's always less than 0. Domain of the function is all real except elemental 1. F of 1 plus is infinity. F of 1 minus is minus infinity. Okay. So I can say that x equal to 1 is the vertical asymptote. X equal to 1 is the vertical asymptote. Next, I need to find out the horizontal asymptote also. Horizontal asymptote means at what value of, at what value of x you are going to get y equal to 0. At x equal to infinity, what is happening? So everyone, limit x tends to infinity. What is 2x plus 4 upon x minus 1? Tell me. You people have done basic limits. Tell me, what is the value? At x equal to infinity, what are you
minus 4.
getting? No.
minus
2.
2. Coefficient of x, right? We have to divide by the coefficient of x in the numerator divided by coefficient of x in the denominator. 2. Right, Rishabh and Imon, you people know this, right? These basic limits.
Yes, sir.
Okay. Tell me, Shijita, Shubhangi, Somali, are you people getting? Adrito,
Yes, sir.
Rasheshwari, Anvesha, are you people getting?
Yes, sir.
Okay. So can I say y equal to 2 is the horizontal asymptote? Y equal to 2 is the horizontal asymptote.
Yes, sir.
Okay. So this is how we can find out horizontal vertical asymptotes, everyone. Always remember. So everyone, how will the graph look like? Okay. So this is the horizontal asymptote y equal to 2. This is the vertical asymptote x equal to 1. Okay. The graph will be hyperbolic. It will look somewhat like this. Anyone having any doubt, you can ask me now. So tell me, how many roots will this equation have?
So 1.
One.
So 1.
One. One root. Okay. Very simple. Adrisha, are you getting?
Yes, sir.
Okay.
Sir, could you scroll up to
Yes.
so was it 2x plus 4 or 2x plus 1?
I wrote 2x plus 1. No, 2x plus 4 only.
Oh, I copied it.
See. Okay. Okay. So this is how the graph will look
So
like.
we will always use that x tends to infinity to find the horizontal asymptote.
Yes, because asymptotes are tangents at infinity, right? So
Yes,
we
sir.
need to find out what is happening at x equal to infinity, what is happening at y equal to infinity. Is it clear, Shashwatu? Yes. Okay. So this is how the graph will look like. And if I ask you what is the range will be all real except elemental 2. We cannot achieve 2. Okay. So you people also try one problem. Draw the graph of, question number 3. Draw the graph of 2x minus 4 upon 3x plus 5. Solve.
Sir, can you please scroll up for once?
Yes.
Yes, sir, done.
Done. Okay. Quickly draw. Once you have done it, send your graph. Find out the values at critical points. what is happening at minus 5 by 3 plus minus 5 by 3 minus. Okay, Ritam, there's a slight mistake. You're making mistake with the graph. Check it. Ahir, check your graph. Shvankit, also check your graph. Adrija, also check your graph. Everyone pay attention in this one. Okay, you have to be careful. You need to understand whether the function is
Sir,
increasing
one
or decreasing. Okay. Rishabh, check your graph. Yes, Imon, your graph is absolutely correct. Sanvesha, check your graph. Okay, you need to understand whether the graph is increasing, decreasing, what is happening at critical points. Yes, Rishabh, your graph is correct. Shashwata, your graph is correct. Okay, let me start. Adrija, check your graph. So first of all, differentiate and see whether the graph is increasing or decreasing. You'll be able to get the idea. or if your graph is correct, everyone pay attention. So first of all, you differentiate. Okay. See whether the function is increasing or decreasing. Y is equal to 2x minus 4 upon 3x plus 5. This implies y dash is equal to 3x plus 5 into d by dx of 2x minus 4. Okay. Minus 2x minus 4 into d by dx of 3x plus 5 divided by 3x plus 5 whole square. Okay, you will see that in the numerator you are going to get 2 3s are 6x plus 10 minus 2 3s are 6x, and then uh, minus minus plus 12 upon 3x plus 5 whole square. Okay, 6x will get cancelled. You are going to get 22 upon 3x plus 5 whole square. This is greater than 0. This implies the function is always increasing. You have to draw an increasing graph. Function is always increasing. Okay. Yes, Shavankit, now you are correct. Okay. Let us find out the values at critical points, at the asymptotes. Okay. You can understand that the domain of the function is all real minus 5 by 3. Okay. So let us start finding what is f of minus 5 by 3 plus f of minus 5 by 3 minus. If a limit extends to infinity, what is happening? 2x minus 4 upon 3x plus 5. This will be equal to 2 by 3. F of minus 5 by 3 plus f of minus 5 by 3 plus will be equal to
Same thing.
okay, let me see. F of minus 5 by 3 plus. Okay, denominator will be 0 plus. Okay. And 2 into minus 5 by 3. 2 into minus 5 by 3 minus 4 will be negative. So something negative divided by 0 plus. What will happen? Tell me. Something negative divided by 0 plus. What will happen? Will it be positive infinity or negative infinity? Tell me. Wait, I'm writing it down.
Negative infinity.
Negative infinity. Something negative in the numerator divided by 0 plus. This will tend to minus infinity. Next, f of minus 5 by 3 minus. In the numerator, you will get something negative divided by 0 minus. You will get positive infinity. Are you people getting? Now let us draw the graph. First of all, draw the asymptotes. Remember, you have to draw an increasing graph. Yes, Ahir, your graph is correct now. Formally, your graph is correct. So x equal to 2 by 3 is the horizontal asymptote. Y equal to minus 5 by 3 is the vertical asymptote. At x equal to minus 5 by 3 plus, you are getting negative infinity. That means over here. Okay, so the graph will look somewhat like this. And see, it is increasing. Can you people realize this? It is increasing. Okay. And 5 by 3 minus, it will be minus infinity. It will be infinity. So this will give us somewhat like this. Anyone having any doubt, you can ask me now. Tell me. Shubhangi, is it clear? Madhurjo, Rasheshwari, Anvesha, Adrito, is it clear?
Yes.
Okay.
Yes, sir.
Next. Pratyay, have you understood? Okay, next. Graph of root over, y equal to root over linear. Okay, how to draw the graph of y equal to root over linear? Pay attention. For example, y equal to root over x. What is the domain? Okay, domain is
Close 0 to infinity.
close 0 to infinity. So we need to only think about close 0 to infinity only. Now, everyone, it will definitely be a curve. But will it be concave up curve or concave down curve? How will we get to know? By differentiating. Y dash will be equal to 1 by 2 root over x. Right, everyone? Y dash will be equal to 1 by 2 root over x. Okay. Next. What is y double dash? D2y by dx square will be equal to 1 by 2 into x to the power minus half minus 1 and multiplied by minus half. Okay. This will be equal to minus 1 by 4 into x to the power minus 3 by 2. Okay. So tell me, is it positive or negative? D2y by dx square? What do you think? This is positive or negative? This is negative for x greater than 0. This implies d2y by dx square is less than 0. Hence, y equal to root over x is concave down. Is concave down. How will it look like? How will the graph look like? Pay attention. So it's y equal to root over x. It will start from 0. It will look somewhat like this. Is it clear, everyone? Tell me. What is the range? Range is from close 0 to infinity. So everyone try this out. Question number 4. Draw the graph find the domain and range of find the domain and range of y equal to y equal to 3 plus root over x plus 1. Solve. Okay, after this, you people will do this one. Question number 5. Find the range of number 1. Tan of pi by 4 into signum function of x square minus 1. Part 2. Mod of x square minus x minus 6. Now closed. Just start sending me your answer, everyone. Yes, Ritam, your answer is absolutely correct. Wait a minute. Oh, yes, your answer is absolutely correct. Ahir, your answer is correct. Write down the domain and range as well. Okay. Imon, Imon, you're making some slight mistake. Domain is correct. You're making a mistake with range and graph. Rishabh, Rishabh, domain, range, and graph are correct. Advija, Advija, domain, range, and graph is correct. Swankit, domain, range, and graph is correct. Rhythm 5 part 1 is correct. Yes. Ahir, your answer is correct. Okay, let us start, everyone. And Rhythm 5 part 2 is also correct. Okay, everyone, let us start with the domain, range, and graph of y equal to 3 plus root over x plus 1. So for domain of the function, this will be equal to, for domain of the function, x plus 1 must be greater than or equal to 0. This implies x must be greater than or equal to minus 1. So domain of the function will be minus 1 to infinity. Next. Okay, Abhisha, you have written the domain range correctly, but graph is not correct. Okay, so domain is minus 1 to infinity. What is the range? Let us see the range. Range of the function y equal to 3 plus root over x plus 1. Root over something will lie between 0 to infinity. Okay, so 3 plus 0 to infinity. This will be closed open 3 to infinity. Tell me, Shania, are you getting?
Yes, sir.
Okay. Madhurjo, can you understand?
Yes.
Okay. A minute. Pratyay, Ariv, are you people getting?
Yes, sir. Actually, my phone's
Okay.
charge is over. That's why I'm unable to see.
Okay. Abhiksha, Abhigyan, are you getting this? Okay. Let us start.
Yes.
At minus 1, you are going to get 3. At x equal to minus 1, you are going to get 3. So the graph will start from minus 1, comma 3. Okay, this is how it is going to look like. Is it clear to everyone? Tell me, Abhiksha, is it clear?
Yes, sir.
Okay. Okay, everyone solve 5 part 1 and 2? Yes. Ahir, your answers are correct. Imon, yes,
Yes,
Imon,
sir.
your answer is correct. Shamili, Shamili, I hope you have understood the graph. Adito, your answers are correct. Rishabh, part 1 is correct. You're making a mistake with part 2. Swankit, Swankit, check your. Okay, wait. Swankit, where have you written the answer of part 1? You have to find out the range. Swankit, you have to find out the range of 5 part 1 and 2. Aditya, part 1 and 2 are correct. Shubhangi, Your graph is correct. Okay, 5 part 1, everyone. Signum of x square minus 1. Pay attention, everyone. We need to find out the range of tan of pi by 4 into signum of x square minus 1. Now, x square minus 1 can be both positive, negative, and 0 as well. Right, 5 part 1. Signum of x square minus 1 can be both positive, negative, pay attention, can be positive, negative, 0, anything. Minus 1, 0, 1, anything. So what is tan of pi by 4 into 1? What is tan pi by 4? 1. What is tan pi by 4 into 0? That is 0. What is tan pi by 4 into minus 1? Tan of minus 1, tan of minus pi by 4, that is minus 1. So range of the function will be elemental minus 1, 0, 1. Next, part 2. Yes, Shubhankit, your range is correct. Yes, Shubhangi, your answers are correct.
Sir, can we
Soifsha,
show 5 to
Soifsha, your answer is correct. We need to find out the range of mod of x square minus x minus 6. Okay, let us start. Okay, mod of x square minus x minus 6. So first of all, we need to find out the minimum value of the quadratic. Okay, what is the minimum value? Maximum value will be infinity. Minimum value of the quadratic, x
0.
square minus x minus 6. Only x square minus x minus 6. It will be 4 into 1 into minus 6 minus of minus 1 whole square divided by 4 into 1. This will give us minus 24 minus 1. That will give us minus 25 by 4. So can I say the range of the function is mod of close brackets minus 25 by 4 comma infinity. Okay. Now, since it is mod, we cannot take negative values. All the negative values will become positive only. It will be closed 0 to infinity.
Yes.
I hope it is clear to everyone. Yes. Next, there is another kind of question, everyone. Try this out. Question number 6. Okay, whenever it is given 1 by quadratic or quadratic by quadratic, wait, let me see. There was another problem like this. Yes. Find the range of number 1, y equal to x square minus x plus 1 divided by x square plus x plus 1. Okay, and number 2, y equal to 1 by x square plus x plus 1. Solve. Okay, after this, question number 7. Find the domain of root over x to power 14 minus x to power 11 plus x to power 6 minus x cube plus x square plus 1. Okay, over here add one more, part 3, y equal to x minus 1 into x minus 2 into x minus 3 upon x minus 2 into x minus 3. Solve. Yes, Rhythm 6 part 1 is correct. Okay, I'm solving 6 part 1, everyone, pay attention. Y equal to x square minus x plus 1 upon x square plus x plus 1. Whenever you are given quadratic by quadratic, we already did this in quadratic equations, but again I'm showing you. Y equal to x square minus x plus 1 upon x square plus x plus 1. Okay, it has to be real. Y has to be real. So cross multiply, you are going to get y into x square plus x plus 1 is equal to x square minus x plus 1. Okay, this implies x square into y minus 1 plus x into y plus 1 plus y minus 1 is equal to 0. Okay, we'll get a quadratic. Now there are two cases. Case 1, when y is equal to 1, then it won't be a quadratic anymore. When y is equal to 1, what will happen? X square minus x plus 1 will be equal to x square plus x plus 1. Let us see whether we are getting any value of x or not. X square gets cancelled. You are going to get x is equal to 0. Okay. So for y equal to 1, we are getting a certain value of x. Therefore, y equal to 1 should be in the range. Are you people getting? Y equal to 1 should be in the range. Okay, next. Case 2. When y is not equal to 1. So what should we apply? Tell me. When y is not equal to 1, and since x is real, so what should be the discriminant?
Equal to 0.
Discriminant should be greater than or equal to 0. So let us apply. Since x is real, discriminant should be greater than or equal to 0. This implies, yes, I'm checking. Y plus 1 whole square minus 4 into y minus 1 into y minus 1 must be greater than or equal to 0. Rhythm, I think you're making a slight mistake in 6 part 3. Shashwata, your answer is correct.
Sir, can you show the question?
So can we use that method that I used?
Wait, let me see. Yes, yes, Shashwata, you're absolutely correct. Okay, I'm going to show this method also over here. Okay, so this is method 1. Method 2 also I'll show. Okay, everyone pay attention. Method 2, we have discussed it in complex numbers also. This kind of method I've shown in complex numbers also, if you people remember. Anyways, so y plus 1 whole square minus of 4 into y minus 1 into y minus 1. This implies y square plus 2y plus 1 minus 4 into y square minus 2y plus 1 must be greater than or equal to 0. This implies y square minus 4y square is minus 3y square plus 2y plus 8y plus 10y plus 1 minus 4 is minus 3 must be greater than or equal to 0. This implies 3y square minus 10y plus 3 must be less than or equal to 0. This implies y minus 3 into y minus 1 by 3 must be less than or equal to 0. This implies y belongs to 1 by 3 comma 3. Okay. Now just check whether you have included 1 or not. Yes, you have included 1. So this is the range. Tell me, is it clear to everyone? If there's anyone having any doubt, you can ask me now. Tell me. Imon, are you getting?
Yes,
Rishabh,
sir.
Yashashwari, Anvesha, Shijita,
Yes.
Shreyasi, are you people getting?
Yes.
Shijita, have you understood?
Yes, I did this all.
Okay. Shubhangi, Shubhankit, Shamali, are you people getting?
Yes, sir.
Yes, sir.
Okay. Actually, I'm going to show method 2 also. Okay, Shashwato has done this second method. You people can follow this second method also. So it's given y equal to x square minus x plus 1 upon x square plus x plus 1. So everyone, can we write it as x square plus x plus 1 minus 2x upon x square plus x plus 1? This will be equal to 1 minus 2x upon x square plus x plus 1. So what you do is you divide by x in the numerator and denominator. You'll get 1 minus 2 upon x plus 1 by x plus 1. Tell me, are you people getting up to this much? Okay. After this, you people see that uh, over here, for x greater than 0, x plus 1 by x will lie from 2 to infinity, right? So for x greater than 0, you are going to get y is equal to 1 minus 2 upon 2 comma infinity plus 1. This will be equal to 1 minus 2 upon 2 plus 1 is 3, 3 comma infinity. Okay. Now what is 2 upon 3? 2 upon 3 is 2 upon 3. So close 2 upon 3. Okay. But 2 upon infinity is 0. So open 0 to 2 upon 3. Closed. Okay. This will be equal to 1 minus 0 is 1. And 1 minus 0 is 1. And 1 to 2 by 3 is 1 minus 2 by 3 is 1 by 3. So it will be closed 1 by 3 to 1. Tell me, is it clear to everyone? Next. For x less than 0, what will happen? You'll get y is equal to 1 minus 2 upon minus infinity, comma minus 2 closed plus 1. This will be equal to 1 minus 2 upon minus infinity plus 1 is minus infinity. Minus 2 plus 1 is minus 1 closed. This will be equal to 1 minus 2 upon minus infinity is 0. And 2 upon minus 1 will give us minus 2 closed. So this will give us 1 minus 0 is 1 open. And then 3 closed. Okay. Next, you need to check whether y equal to 1 should be included or not. When you substitute y equal to 1, you will see that x square minus x plus 1 can be equal to x square plus x plus 1. Okay. Therefore, y equal to 1 should be included. So y belongs to 1 comma 3. 1 by 3 comma 3. Closed. Okay, this is another method. Whichever method you want to follow. Okay, next I have given another problem. Try it out. Yes, Shashwato, part 2 is correct. Or if part 2 is correct, part 3 is also correct. If Joyatra, part 2 is correct. Ahir, part 1 is correct. Imon, part 2 is correct. Okay, part 2 I am solving y equal to 1 by x square plus x plus 1. Let us start, everyone. So we are getting 1 upon quadratic. Or if 7, question number 7 is correct. Okay, I'm solving part 3, everyone. Sorry, part 2. Y equal to 1 upon x square plus x plus 1. Okay, so whenever you are getting 1 upon quadratic, what you do is you make it a perfect square. This will be 1 by x square plus 2 into x into half plus half whole square plus 1 minus half whole square. I have added half whole square and subtracted half whole square. This will be 1 by x plus half whole square. 1 minus 1 by 4 is 3 by 4. Okay, everyone. Now see, it is a perfect square, everyone. Where does perfect square lies? I mean, where do perfect square lies?
Greater than 0, so this is 0. So
0 to infinity. So it will be 1 by closed open 0 to infinity plus 3 by 4. So it will be 1 by 0 plus 3 by 4 is 3 by 4, comma infinity plus 3 by 4 is infinity. Now 1 by infinity is 0. 1 by 3 by 4 is 4 by 3. So it will be open closed 0 comma 4 by 3. Anyone having any doubt, you can ask me. Yes, Aisha, your answer is correct. Abhigyan, have you understood? Shreyasi, have you understood?
Yes, sir.
Shania, is it clear?
Yes, sir.
Okay, okay. Everyone try out number 7. Oh, sorry, 6 part 3. Uh, okay, Shashwato, there's a slight mistake. Yes, I hear part 2 was correct. Okay. Yes, Shamli, your answer is correct. Okay, let's start. Y equal to x minus 1 by x minus into x minus 2 into x minus 3 upon x minus 2 into x minus 3. So everyone pay attention. X minus 1 into x minus 2 into x minus 3 upon x minus 2 into x minus 3. So you people can understand that x minus 2 and x minus 2 gets cancelled, x minus 3 gets cancelled. But remember, y is equal to x minus 1 when x is not equal to 2 comma 3. X cannot be equal to 2 and x cannot be equal to 3. Okay, y is equal to x minus 1. Okay, so everyone, if x is not equal to 2, y cannot be equal to 2 minus 1. That is, y cannot be equal to 1. And if x is not equal to 3, y cannot be equal to 3 minus 1, which implies y cannot be equal to 2. Therefore, the range of the function is all real minus elemental 1 comma 2. Tell me, is it clear to everyone? Yes, Ahir, number 7 is correct. Yes, Ritam, have you understood now? Rishabh, are you getting? Shubhangi,
Yes, sir.
Adrito,
Yes, sir.
Anvesha, Abhigyan, Rasheshwari, Pratyay, are people getting?
Yes.
Yes,
Yes,
sir.
Shanaya, are you getting?
Yes, sir.
Okay. Next, solve number 7, everyone. Okay, everyone see number 7. See, of course, the expression inside the root should be greater than or equal to 0. Then only the function is defined. If you notice, everyone, if you notice that we only need to think about this expression. Okay, if you notice, we only need to think about this expression. X power 14 minus x power 11 plus x power 6 minus x cube. plus x square plus 1. Okay. Acha everyone, if x is, this is number 7. If x is greater than or equal to 1, okay, you will see x power 14 minus x power 11 is
Greater than.
greater than 0. X power 6 minus x cube is greater than 0. X square plus 1 is greater than 0. So that means x greater than or equal to 1 should be included. This is there in our domain. Next, what will happen when x is less than or equal to 0? If x is less than or equal to 0, okay, if x is less than or equal to 0, what will happen? Okay, means x is negative. Acha, if x is negative, all the odd powers, that is minus x to power 11 will be greater than 0. Minus x cube will also be greater than 0. This implies x greater than or x less than or equal to 0 is also there in our domain. Are you people getting? X greater than or equal to 1 is there in our domain. X less than or equal to 0 is also there in our domain. Now we need to check what will happen between 0 and 1. If x belongs to 0, comma 1, tell me, what is x square minus x cube? Tell me, what is x square minus x cube?
Greater than 0.
Greater than 0? If x belongs to 0, comma 1? And what is x to power 6 minus x to power 11? Tell me.
Greater than 0.
Greater than 0. So can I say that the whole thing is there in the domain? Therefore, domain is all real. Is it clear to everyone? Iman, have you understood?
Yes, sir.
Okay. Next. Range of linear by quadratic. Range of linear by quadratic. Quadratic by quadratic. Quadratic by linear. All these are already done. Okay, everyone. Already done in quadratic equations chapter. Okay. So if you want the PDF or if you don't have the PDF, let me know. You can refer quadratic equations chapter. I have written this so that you people remember that you have to refer to quadratic equations PDF. Okay. And it will be there in the functions exam. So I have to go through it. Okay. Next. Question number 8. Find the number of roots of the function f of x is equal to 1 upon x plus 1 whole cube minus 3x plus sine x. Next. Question number 9. Px is a polynomial. Px is a polynomial function with integer coefficients with integer coefficients. Remainder when px is divided by x minus 1 is 1, and remainder when p of x is divided by x minus 4 is 10. Find the remainder. Find the remainder when p of x is divided by x minus 1 into x minus 4. Solve.
Sir, you are muted.
Okay, can everyone hear me? Hello, can everyone hear me
Yes,
now?
sir.
Yes, Ahir, Adrija, and Oriv, your answers are correct. Everyone pay attention. In order to find out the number of fruits, I'm going to draw the graph. Okay, everyone? So in order to draw the graph, what do I need? I need its vertical asymptote. I mean, if there exists any. Okay. From here only we can understand that x equal to minus 1 is the vertical asymptote. Right. And what else we need? We need some certain values at some critical points. And we also need to see whether the function is increasing, decreasing. Okay. These things we require. Let's see. So everyone, what is f dash x? F dash x will be equal to minus 3 upon x plus 1 whole to the power 4 minus 3 plus cos x. Okay. This is what f dash x is. Now everyone, this is negative. And this one, what do you think? Minus 3 plus cos x is positive or negative? Tell me everyone. Minus 3 plus cos x is negative, right? Okay. So what can we say? F dash x is always less than 0. This implies f is a decreasing function. F is a decreasing function. If you people have any doubt, you can ask me. Next. Also, domain of the function is r minus 1. Therefore, x equal to minus 1 is a vertical asymptote. Okay, these are the things we have already got. Achha, what will happen at infinity? Okay, let's see. Let x, I mean, limit x tends to infinity, what will happen? Okay, limit x tends to infinity. We have got 1 upon x plus 1 whole cube minus 3x plus sine x. Okay, this will be equal to 1 upon infinity is 0 minus infinity plus sine of infinity. It will oscillate between minus 1 and 1. Okay, so I can say that it is in minus infinity. Okay, and what will happen at minus infinity? Limit x tends to minus infinity. Vaibsha, are you getting 1 upon minus infinity minus 3 into minus infinity plus it will oscillate between minus 1 and 1. So this will be equal to infinity. So I've got the values at infinity and minus infinity. Let us see what will happen at f of 1 plus. F of 1 plus is 1 upon, sorry, minus 1 plus. Okay, f of minus 1 plus will be equal to 1 upon 0 plus minus 3 into minus 1 plus sine of minus 1. So 1 upon 0 plus is infinity. So it will come from infinity. And similarly, f of minus 1 minus, this will be minus infinity. Okay, so let us plot the graph. Okay, Imon, are you getting? Tell me.
Yes, sir.
Okay, x equal to minus 1 is the vertical asymptote, everyone. Minus 1 plus will be infinity. Means the graph will start from here. Okay, at x equal to infinity, it is minus infinity. So this is how it will look like. It's a decreasing function. It's a decreasing function. Okay, somewhat like this. Okay, next. At x equal to minus 1 minus, it is minus infinity. So it will look somewhat like this. Tell me, are you people getting? If there is anyone having any doubt, you can ask me now. Okay. So everyone, how many roots are we getting? Therefore, there are 2 roots. Okay. If there's anyone having any doubt, you can ask me. Okay. Next. Number 9. You need to find. So number 9, we have done it in class 8. We have done it in class 9. We have done it in class 10 also. If you people remember. We have done it so many times, this kind of question. Yes, Ahir, your answer is correct. So you people tell me that if p of x, a polynomial, is divided by quadratic polynomial, what kind of a remainder you will get? Tell me. If a polynomial is divided by a quadratic polynomial, remainder has to be linear, right, everyone? Tell me. This is number 9. So whenever p of x is divided by a quadratic polynomial. Is divided by a quadratic. Everyone knows this, right? Rishabh, you know?
Yes, sir.
Okay. Ivan, are you getting quadratic polynomial?
Yes, sir. Yes.
Okay. Remainder is linear. Okay. So let the remainder be ax plus b. Tell me, Adrito, Rasheshwari, Anvesha, are you people getting? Shreyasi, Shubhangi, Shovankit, are you people getting?
Yes.
Yes.
Yes,
Let
sir.
the remainder be ax plus b. Pratyay, are you getting? Arif,
Yes,
Atiksha,
sir.
Abhigyan, are you people getting?
Yes, sir.
Okay. So by division algorithm, okay, p of x will be equal to x minus 1 into x minus 4 into q of x, quotient, dividend is equal to divisor into quotient, plus remainder. Okay. Now, what is p of 1? It is given that the remainder, when p of x is divided by x minus 1, it is 1. So p of 1 is 1. P of 1 will be equal to a plus b, which is equal to 1. And p of 4 is equal to 10. So 4a plus b is equal to 10. So I've got two equations in two variables. Let us subtract. Minus 3a is equal to minus 9. This implies a is equal to 3. If a is equal to 3, b is equal to minus 2. Therefore, remainder is px minus 2. Okay, tell me. Anyone having any doubt? You can ask me now.
No, sir.
Okay. Acha, one last topic I'm going to discuss today. That is equal or identical functions. It's a very small topic. Equal or identical functions. Okay. So two functions are said to be identical. Two functions are said to be identical or equal if their graph if their graph overlaps. Okay. So two functions f and g are said to be equal are said to be equal if number one, domain of f is equal to domain of g. Okay, their domains are same. Number two, range of f is equal to range of g. Okay, number three, their functional values are also same. F of x is equal to g of x for every x belonging to their common domain. Belonging to their common domain. Okay, f of x must be equal to g of x. As a note, what do you think? Sin x and cos x, are they identical functions? Their domain is same, range is same.
No, sir.
Sin x and cos x have same domain and range. Have same domain and range. But sin x is not equal to cos x for all x belongs to real. Okay, sin x is not equal to cos x for all x belongs to real. See, this is the graph of cos x. Okay, and this is the graph of sin x. Okay, they will be equal at certain points, but not every time. Okay, next. Another question, question number 10. You just write yes or no, okay? Are y1 equal to ln x square and y2 equal to 2 ln x identical? Just write yes or no. Yes, Imon, Shashwato, your answers are correct. Arif, no, you are making a mistake. Anvisha, your answer is correct. Ahir, your answer is correct. Shomli, your answer is correct. Domain of y1. Yes, Pratyay, Adrija, your answer is correct. Domain of y1 is all real except elemental 0. But domain of y2 is
R plus.
r plus. Okay, so they are not identical. They are not identical. Remember. Okay, note when n is even, domains of ln x to the power n and n into ln x will not be same when n is even. Okay, but domain will be same, but their domain will be same when n is odd. Will be same when n is odd. Okay, next, another one. Question number 11. Are the following functions identical or not? Are the following functions identical or not? Okay, you have to raise your hand. Okay, no need to write, just raise your hand. Number 1, tan x and 1 by cot x. Raise your hand. Tan x and 1 by cot x. You have to tell me whether they are identical or not. Okay, so somebody is raised. Yes, you won't tell me. Are they
Yes,
identical?
sir, they are identical.
They are. No, you are making a mistake. Okay. Somebody, can you tell me why they are not identical? They cannot hear anything. Cannot hear anything. Not properly. Okay, Adrija, you tell me. Can you tell me,
Because
Adrija?
at specific values of x, tan x is not equals to 0, but cot x is equal to 0.
Not like this. Tell me a specific answer. Okay, he tell me why they are not identical.
Sir, tan x can be 0 but cot x cannot be 0.
Tan x can be 0, but cot x cannot be 0.
Sir, can I try again?
Why cot x cannot be 0? Acha, cot x cannot be 0. Okay. Okay, okay. Yeah,
Not
yes,
defined in
it's
the
correct. It's correct only. It's correct only. Okay. Acha,
So also the range are not equal.
the range,
That's not
the
defined.
range. Okay, their domain you can say. Domain of tan x, domain of tan x is r minus 2n plus 1 whole pi by 2, right?
Yes, sir.
Okay. But domain of 1 by cot x, remember, cot x should not be equal to 0, will be r minus
N pi.
n pi, also minus 2n plus 1 whole pi by 2. Okay, both the things should not be in the range. Neither n pi nor 2n plus 1 whole pi by 2. First of all, cot x should be defined. Also, cot x cannot be equal to 0. Okay. Next, are you people able to understand tan x and 1 by cot x? Next, another one. Raise your hand. F of x is equal to sec x and g of x is equal to 1 by cos x. Tell me, are they identical? Yes or no? F of x equal to sec x. Yes, I tell me.
Yes, sir, they are identical.
Timon, what do you think? They are identical or not?
Yes, sir, they are identical.
They are identical. Okay, everything is same. Domain range sec x is also equal to 1 by cos x. Okay. One last one. Number 3. Signum of x square plus 1 and g of x is equal to and sin square x plus cos square x. Raise your hand. Are they identical? Yes, Rishabh, tell me. Rishabh, tell me. Okay, I'm unable to hear you, Rishabh.
No, sir, they should identical.
Arif, what do you think? They are identical or not?
Yes, sir, they are identical.
Jayatra,
Yes, sir, identical.
Imon,
Yes, sir, identical.
Shashwata, what do you think?
So not identical.
Not identical. Okay, so only you said not identical. Tell me why. Shashwata,
So can I tell the reason?
tell me.
Sir, you gave this question earlier also, and in that answer you told it was not identical. I
Where?
forgot the reason.
Identical functions, I'm doing it for the first time.
No, sir, you gave
Yes.
this question earlier also in quadratic, I guess.
Quadratic, where I discuss signum function.
Sir, I think in ITF.
In
Oh yes,
ITF,
yes, ITF, yeah.
over there I said not identical.
It's identical only.
They are identical. If I had said that means I might have
Sir,
said
they
by
are not
mistake.
identical for, I think, complex.
Complex, we are not discussing
For real
complex.
numbers, it is defined for the same range.
Yes, yes, they are identical. Okay. Uh, acha, one last one. One last one, everyone. So similarly, tell me what is sec square x minus tan square x and 1. Raise your hand. Are they identical? What do you think? Raise hand. Arif, tell me.
Sir, identical.
Abhigyan,
Sir, identical.
Mahir,
They're not identical.
Adrija,
Identical.
Imon,
Not identical.
Rishabh,
It's identical.
Adiksha.
Sir, identical.
Okay. So actually, those who said not identical, they are correct. Because try to understand domain. What is the
Domain
domain
is
of?
not defined
Yes,
separately.
exactly. Domain of sec square x minus tan square x. We need to also think about the domain, right? Domain range. Okay. Domain of sec square x minus tan square x is r minus 2n plus 1 whole pi by 2. Okay. But domain of 1 is all real. Is it clear to everyone? It's all real.
Yes.
Hence, they are not identical. Okay. So till now, anyone having any doubt? Tell me. Shreyasi, have you understood identical functions? Shreyasi, Sanaya, did you people understand? Shwankit, is it clear?
Yes, sir.
Okay. Okay, so I think everyone, we can keep it till now. Next class, after the test, I'm going to start with classification of functions. Okay.
Sir, next class, is there any test? This
There is
Sunday?
a test, but you people can skip it. You people join today only. You and
No, sir. This Sunday means 5th.
yes, Sunday.
Yes, sir, I will give.
You'll give? Okay.
Yes, sir.
Okay.
Okay, sir.
Okay.
Sir, I'll
Okay.
give on Monday.
Okay. There are two slots. Okay.
Can you send
Okay.
tomorrow's mains paper in the group to me?
Yes, definitely. All the mains paper, whatever is happening, I'll be sending it. Okay. Okay. So till then, everyone, we can keep it till now. Next class will again continue. Thank you, everyone, and good night, everyone.
Good night.
Thank
Good
you,
night,
sir.
everyone. Yes.
Welcome, good night.
Yes.
It's